What's up, ladies and gents? It's Mr. Cloud coming from my home in North Belmore, New York, and it's time for another week of Earth Science at Home Distance Learning e-learning screencast with your host, Mr. Cloud, the Earth Science teacher. And this week, what we're going to be doing is we're going to be getting into a particular topic that I want you to guess. Now, how are we going to guess that? But we're going to look at a few images here, and it's going to be your job to figure out the common theme of all these images. And to figure out the theme, you'll figure out the topic of the lesson today. Here we go. The first image we can see here is from Bryce Canyon in Utah, which happens to be a national park, right? And you see an arch here. And if you're one of my earth science students, or if you've taken earth science this year and you've taken geology, you should be able to identify what rock that is. You probably would have to go to page 7 of the reference table to try to figure it out. Here's our next image. Boom. Here are the Grand Tetons in Wyoming. Man, I'd love to ski these. Plenty of ice wedging happening at high elevations. The fjords of Norway. Man, glaciers must have ripped through here, creating this U-shaped valley with incredible relief. The karst topography of the Cone Mountains of China. And lastly, Glacier National Park in Montana. Well, what do all these things have in common? Well, I'm guessing that you probably guessed it. All these areas have been weathered. So let's talk about what weathering is. There are two main categories. We're going to break them down today. Let's get into it. All right, this video is going to break down weathering. There are two main types of weathering. The first, guys, is physical. The next is chemical weathering. Physical weathering can be broken down to three different main types. One is frost action. The second is biological activity. And the third is abrasion. Chemical weathering can be broken down into oxidation, carbonation, and then what's really cool about carbonation, which is when water combines with carbon dioxide and kind of eats away slowly at the bedrock, is it creates these amazing karst topographies around the world, including all the cavern systems that you might see around the world as well. Okay, so what's really the first thing we're going to be getting into? Okay, well, the first thing we're going to really look at, ladies and gents, in this conversation together is we're going to break down all the different types of physical weather. That's the first thing we're going to do. And the second thing we're going to do is we're going to talk about chemical weather. All right, guys, let's get into it. All right, dudes. First things first. Okay. So physical weathering itself, another word for it is physical or mechanical weathering. It's the breakdown of rock into smaller pieces without changing its chemical composition. All right, this really simple diagram here below kind of shows you frost wedging, and we'll talk about that, what that is in a moment. Okay. Ice wedging, guys, really what happens here is you have rainwater that will fall. It'll percolate into different cracks in rock, and we've learned this throughout the year. A phase change will happen when it gets colder outside. Liquid turns into the solid state we call ice during solidification. At cold temperatures, we call this freezing. Okay, and water is really unique because when it freezes, it actually expands. So the water gets in, it expands, and as it slowly expands, it breaks the rock apart. Now, did the chemical composition change? No, the chemical composition didn't change. It just became smaller. The surface area of the rock went up. It broke up into smaller pieces. We call this frost action. Now, what's really cool about this lesson today is there are going to be questions that are in italics that you see down here below. There's going to be 4 questions. And the homework assignment for this week is you're going to have to create a Google Doc and actually answer those 4 questions. Now, the answers to those questions might be in the screencast, but they might not be. So you're going to have to take a look at the reading that I provide to you, the textbook chapter, and also you'll have to go on Google and just search it up, okay? So make sure you pay attention to what those questions are. The first question today is, number 1, potholes commonly form during winter, and as spring approaches, road workers take to the streets to begin fixing many of the roads around our area. What type of weathering is responsible for creating those potholes? Outline the process. Feel free to draw a diagram. It's question 1. Another type of physical weathering that we might see, guys, is going to be biological activity. This is kind of showing you ice wedging again. Oh man, and we're going with question 2 right away. Here we go. All right, where on Earth will ice wedging commonly occur? Provide us with a geographic region where it's common, and why did you choose this location? So 2 questions right off the bat. Remember, there's only 4 through this entire presentation. Okay. The next, guys, is going to be biologic activity. Okay, let me move myself down a little bit so you can see this a little bit better. But if you notice here, what you see, guys, are trees, and you see the roots kind of growing through the different cracks of this rock. And over time, the roots get bigger, they expand, and they crack the rock. Did the rock chemically change? No, it just broke. That's really mechanical or physical weathering at its finest here. Now, in your own personal lives, where would you see this? Right? Well, we're all still kind of at the age that we would ride bikes potentially from one friend's house to another. If you've ever been ripping down the sidewalk and you see one of those jumps on the sidewalk, well, what made that jump? Well, it's pretty much a tree root going right through the cement sidewalk and kind of kicking it up and making a really cool jump to hit with your friends. Okay, so you probably didn't realize that that's a type of physical weathering. It's biologic activity. The third, guys, is going to be called abrasion. What is abrasion? Well, you have to think of erosion to think about abrasion. Okay, weathering and erosion go hand in hand with one another. So whenever you think about erosion, you usually think about weathering and then vice versa. This is one of those situations where they have to work together. Abrasion is the mechanical scraping of a rock surface by friction between rocks and moving particles during their transport. And the transport could be done by the movement of glaciers, wind, waves, gravity, or running water. Okay, so in essence, what's happening here is that rocks are just colliding with one another as they get transported, or sand is being kind of blasted over the top of rock that's there and kind of smoothing it out. We would say those rocks have been abraded. Were they chemically changed? No, they were physically changed. Okay, so here's question number 3. Let me move myself a little bit here for you. Using a Google image search, find a minimum of 2 images that show us how rock appears after it has been abraded by any one of the erosion processes listed above. Provide a caption below each image. Specify if the abrasion took place by wind, running water, waves, etc. So in that Google Doc that you're creating of 4 questions, we want 2 images with 2 captions describing those images really, really well. Okay. The next, guys, is going to be chemical weathering. Okay. All right. So chemical weathering, guys, is the breakdown of rocks due to the chemical reactions occurring between the minerals in rock and the environment. And pretty much you need to have water to have chemical weathering happening. If water is not there, there's just really not going to be much chemical weathering happening. So in terms of factors that affect weathering, the abundance of rainfall will dramatically increase the rate of it. So let me give you an example of what chemical weathering would be. All right, I'm going to show you a mineral that you might have seen when you were identifying minerals earlier in the year. Okay, this is hematite. And hematite, guys, is an iron ore. We can kind of break it up and we can kind of smelt out the iron there, and we can create metals from that. But iron, when it's in the presence of water, all right, will do this. What happened there? Well, really, guys, what happened there is that it rusted. And this is an example of chemical weathering. And really, guys, this mineral here has chemically changed. It's actually weaker than it used to be. It actually rusted. It oxidized. Okay? In the presence of water, it chemically weathered. Okay. So, chemical weathering, oxidation, will be the first one that we talk about, guys. And where have you seen this in your everyday lives? Well, if you've ever left your bike out in the rain, your bike chain was chemically weathered. It oxidized. Okay, so we call this rusting. And here's your balanced chemical equation here going on here. Okay, iron plus 3O2 yields 2Fe2O3, or just iron oxide there. Okay, here's a dramatic image of where chemical weathering really comes into play. This shows you the Carlsbad Caverns in New Mexico, and how the heck did something like this form? Okay, take a look at the scale. Take a look at the people, all right, that are down here. It's just an absolutely massive cavern system in New Mexico. Well, how did this actually happen? Well, you might have guessed it, by chemical weathering. Okay, now, if I was in class, I would probably ask you a +1 question, and I would say, what type of rock is this? Well, if I were to give you some hints, I probably would say that it's a bioclastic rock. In this case, this is not too much of a bioclastic rock, though. This is probably more of a crystalline example, or crystalline example of this particular rock. If you were to take hydrochloric acid and kind of dumped it on it, it would definitely fizz. Could you guess what it is? Use your reference tables to try to figure it out. Pause the video to try to figure out what this might be. Okay. Well, you might have guessed it, guys. It's limestone. So how the heck does this form? Okay. Well, if we look at this sequence of 1, 2, 3, 4, let's break it down for you. All right. So what happens is that rain falls and it mixes with CO2. There's carbon dioxide in the air, and you get a very weak acid. It's called carbonic acid. It's so common, guys, that you could drink it. If you drink soda, you're drinking carbonic acid. Okay. You make soda by carbonating it, just kind of dissolving the CO2 in there at a high pressure, right? So it's really common, and it kind of infiltrates the ground. And over a long period of time, we're talking thousands of years, millions of years, all right, the limestone itself starts to get dissolved, right? The carbonic acid weakens it, and then slowly kind of weathers away. So these cracks here, right, that you see on this side over here, boom, 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 boom. Okay, here we go. So I see these little cracks happening over here. They start to get bigger, and they become bigger cracks like that. Okay, and you get these aquifers, or just kind of groundwater storage that happens here. Now, over time, okay, the water table starts to lower. It gets lower and lower and lower, it lowers down, and then you get these massive voids, all right, that occur here. And these voids, guys, are called caverns. Okay, sorry, my writing's not that great there. Okay, now limestone, or really calcite that's actually dissolved in the water there, will actually drip from the ceilings of these caverns and create stalactites. And then when the calcite dissolved in the water precipitates out when it hits the ground, it makes these mounds called stalagmites. And when they come together, you can have a stalactite that comes down and then a stalagmite that comes from below. And as they get closer and closer and closer to one another, they can become massive columns. So you can see these huge columns that can take a tremendous amount of time to actually build. Here's question number 4 for you. A, New York State has a world famous cavern that has been visited by millions of people for at least 170 years. It's been around for that long. Using a Google search, identify the caverns in New York State. B, once you've identified the caverns, share at least 3 facts about the caverns that might be interest to a geologist. So we want to know about that. Okay? All right, guys. So the process of carbonation we talked about already. Okay? But this breaks it down a little bit more. It just tells you that carbon dioxide easily is combined with water. Okay? Formation of carbonic acid, the equation's written here below. CO2 plus H2O yields carbonic acid. And then what happens then is calcium bicarbonate forms, which becomes really soft, and it kind of breaks down the rock itself. Okay. What can be left behind in the wake of this limestone degradation? Okay. Jumping back to this, take a look at this landscape here, and this is in China. Amazing. When I saw this image, I said to myself, I have to include this so my earth science students could see it. All right, this is an example of karst topography. Karst topography is any region where limestone bedrock is prevalent. What happened here over time is that this area gets a tremendous amount of rainfall. The water falls, seeps into cracks, and then creates these massive like sinkholes and these really steep valleys where these cone mountains are left behind in their wake. And then these become rounded out by continuous rainwater, continuous physical and chemical weathering of the limestone bedrock. Just amazing stuff. This landscape is called karst topography. You can also get massive sinkholes that happen. Take a look at this here. This is called the Cave of Swallows in Mexico. Now, might not look like much here, but take a look at the side image here, guys. Just gigantic. This is so huge that if you took the Empire State Building, you could just place it right within this cavern. It's massive. It goes down over 350 meters from the surface. And some crazy people actually do some base jumping, and they put a parachute on and they jump right in. Don't recommend that you do that. Not a very good idea. Okay? So ladies and gents, we're going to end our conversation there just underneath the 15-minute mark. Okay, keep in mind you have the 4 questions to answer. You're going to fill out a Google Doc and you're going to email it to us for this first half of the week's activity. Hope you learned something about physical and chemical weathering today. I hope to all see you soon in class. Take care, guys.